Okay, so matrix multiplication. So just to start with some vocabulary, some understanding where we're starting with. What is a matrix? So a matrix, which the plural is matrices, just one of those weird pluralized things when you deal with x's, but it's just a rectangular array of numbers. And we often use it to write systems of equations in a form where all you have are the coefficients and the numbers. But you can also think of any tables that you have with numbers or any spreadsheets can be basically turned into a matrix, and then you can work with it, do multiplication, solving, all that kind of stuff. It's just basically like a data table where all you have are numbers. So the notation for matrices is that we have to have the square brackets around it. So sometimes you will see in some textbooks parentheses, but the most common notation is square brackets. And if you don't have those, if you just list the numbers, it's not really a matrix. You need to have at least something to kind of, put the ends together. And we always refer to a matrix as row first and then the column. So we just a row number and then a column number. And then that gives us the dimension, which is like the size of it is just like 2 by 4 would be 2 rows, 4 columns. So that's how we kind of indicate the size of our matrices. And then each item in there is also called an entry, and we reference it based off of the row and the column number. So it's a lot like a spreadsheet where your rows are numbers, your columns are letters, and then you reference like B2 or something, and that's how you reference your the particular cell. Here we have numbers instead of letters as our columns, but we're still referencing a particular cell or element of the matrix. So just vocabulary, I mentioned entries, elements. That's just referring to the numbers or the items inside of it. And we always do row versus column. The dimension is the size. That's again always row by column. And so if you have the same number of rows as columns, it forms a square. So it's called a square matrix. Otherwise, you get what looks like a rectangle. We do often talk about diagonals of matrices. This is, they're used more in, when you're finding like determinants, you'll talk about diagonals. It comes up a lot. Different types of solving, you're going to want ones in the diagonal. And so that's just starting at the top left corner and then going down. And then a row matrix is only a row, a column matrix is only a column. And that's just some particular vocabulary there. So for matrix multiplication, you have two matrices next to each other. And in order for them to multiply, your inside dimensions have to match. And so this example here, we've got A times B. Whatever A is, if it's like 2 times 2 by 4, then B needs to be 4 by something. It could be 4 by anything, but those inside dimensions have to be equal for them to multiply. Otherwise, it doesn't work. And what this means is that we can't reverse the order of multiplication. It's not commutative. So the order that you multiply matters because we have to have specifically the inside dimensions matching. And then your result is basically the size of the outside dimensions. And when you multiply, you're basically taking the row times the column, you multiply matching entries, and then you add them together, and that gives you one number. And you do this if you have a 2 by 2, you're going to have 4 spots in there. So you would do that 4 times. So it's each row times each column. You're doing every combination there. And basically the spots where they overlap, like a row times a column, wherever that overlap is, that's where you put your answer and your resulting matrix. That's what I like to kind of think about, where your answer kind of ends up. Now this is just for reference. These are just particular properties of matrix. You can't reverse the order. There's no commutative property, but you still have the associative property of multiplication. The distributive property still applies. And you can multiply by a single number, and that just multiplies every element by that number. And you can do that associatively as well, but the commutative property does not apply. So let's just start with an example. We're going to do a 2 by 2. So this, if I enter this first matrix here is 2 rows by 2 columns. And we also have 2 rows by 2 columns. And these inside dimensions match, so that means that we can do the multiplication here. And this will give us a 2 by 2 out. And those are coming from these outside numbers. So if you're basically multiplying matrices of the same size, your result is going to be the same size, as long as they're square matrices. So we're just starting here with 2 by 2s because this is the easiest one to kind of look at. So our resulting matrix is going to be size 2 by 2. And so step 1, we multiply row 1 by column 1. So you can see that I've got that highlighted here. So you can see what we're multiplying. And then the answer is going to go in that top left corner. So you can see kind of when I was talking about the overlap here, let me just grab a different highlighter. Like you're multiplying the first row and the first column together. So if you put the matrices on top, they overlap in that first element. And so that's why I said that that's kind of the overlap. That's where your number goes. So the way that this works is your first number gets multiplied by the first number in the next matrix. So your first number in the row gets multiplied by the first number in the column. And then the second number gets multiplied by the second number in your column. And so we're doing 2 times 2, and then you add your answers together. So then we have -1 from the first row times -1 in the second row. So that gives us 4 plus 1, which gives us 5. So we're going to have a 5 here in our top left corner. So once you multiply row 1 by column 1, and you've got your number, then you move on to the next spot. So then it's row 1 times column 2. So you can see that my highlighting, I moved the highlighting here, and now we're looking at the top right because they both have the element here. So that's where they're overlapping. So that's where your answer is going because they both have, when you're looking at what you're multiplying, they're both highlighting that upper right corner. So your answer is in the upper right corner. So it's always the first times the first number here. So in this case, 2 now gets multiplied by -1. And then our second number, -1, gets multiplied by 8. So you're matching up the first pieces together and the second pieces together, and you're just looking across a row and a column. You're always doing row times column. So 2 times -1 is -2. -1 times 8 is -8. And this gives us -10. So that's a -10 in this upper right corner. Are there any questions so far? Okay. So here's what we've got so far. We have 5 in the upper left, -10 in the upper right. Now we want to move to row 2 because we filled in row 1 on our resulting matrix, our answer matrix. So now we need to multiply and fill in row 2. So step 3 would be to multiply row 2 by the first column. And you can see that they both have their overlapping value is that lower left value. My highlights on each matrix both highlight that lower left, so our answer is going to be in the lower left column. So my first number gets multiplied by the first number in the column. So here we've got 2 times 2, and then we have -1 times -1. So 2 times 2 plus, you always add these together, -1 times -1. This gives us 4 plus 1, and we get 5. So we get 5 in this lower left. Once you've filled in there, then you move on to the next column. You stick with your same row, you move to the next column. So now we have that same bottom row, but now we're multiplying by column 2. And now they both have a highlighted spot in the lower right corner. So that's sort of where we're filling in our answer here. So I'm going to be doing 2 times -1, and then -1 times 8. So 2 times -1 plus -1 times 8 gives us -2 plus -8, and we get -10. So we get another -10 there in the lower right corner. And so our answer, our matrix that our answer of the multiplication basically is this matrix on the right. So your answer is always a matrix, and it's going to be 5, -10, 5, -10. So I want you to kind of watch the pattern here when you're multiplying. You're doing row times column, then you do the same row to the next column, and you just keep repeating that until you run out of columns. And then you move on to the next row, and then you do the same thing. Second row, column, move over, run out of row until you run out of columns. And then you just keep going with each row until you've kind of run out of space. So that's basically how you're multiplying matrices. And so this is an example with just a 2x2. And so now I'm going to do multiple examples with other sizes, like a rectangular times a square. We've got some word problems, so we've got lots of practice coming up here. So here we've got, this has 2 rows, 3 columns. So we have a 2x3 multiplied by 2x2. So can you multiply that matrix? The answer is no, because these inside parts need to match. They have to be the same number, and they are not the same number. It does not work because you're doing row times column. And so if I try to multiply the first row by the first column, I run out of entries, because I would do 6 times 8, then 0 times 4, and then I would have nothing to multiply the 3 by. I run out of numbers, basically. So we can't multiply this in this particular order. So it just can't be done. We don't even really have an answer. There's just no answer. You just can't do it. So let's rewrite this and put it in the other order, because that way we can multiply it. So if we put our 2x2 matrix first, 8, 4, -1, -3, so that's a 2x2, and then multiply it by our 2x3, now our insides match, and we can do this multiplication. And our answer is going to give us a 2x3 matrix. So our insides match. Let's use the highlighter here. So we've got 2 and 2 there. The inside dimensions match. And then our answer is going to be the outside dimensions 2 by 3. So we're going to end up with a 2x3 matrix, 2 rows, 3 columns. So I'm going to show you how you would show your work for this by hand, because what I did on the previous example, I was just kind of walking you through each one step, 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 but that's not normally how we show our work. So I like to use highlighters, but if you're doing this on paper, that's a bit harder to do, because then you're constantly erasing, or you can't, so you just have to kind of think about it first row by first column, however you want to show your work there. But we're doing 8 times 6. So the nice thing about having a tablet is that I can, erase these later with the highlighting and stuff like that. But we're going to do 8 times 6 plus, and then -1 times -1. And I usually don't actually do that multiplication and division right away. I fill in what my math is first. And then my next step, after I fill in all of the pieces of what I'm actually doing, then I will do the multiplication. So that is to get the first spot. And then we want to do that first row times the second column. So we're going to have 8 times 0 right here. And I have to leave a gap here so that it doesn't look like you're combining these together. And then we're doing 8 times -4. Not 8, sorry. Very common mistake that people will make. I just did that too. -1 times -4. So if you have to draw arrows, that's how I realized my mistake. I'm like, wait a minute, I have too many arrows coming from 8. You can use the arrows to kind of keep track of what you're doing here. So now we have to do it with the third column. So let's see if I can erase my stuff without messing up anything else. So now we're doing that first row times the third column. So we have 8 times 3 plus, and then the -1 times 0. And then that will be the end of that first row. So it looks kind of messy when you're doing this. Usually what I'll do is do the multiplication and addition on my calculator in one step and just write the answer. But when you're learning, that's not good, because then you don't know where you messed up. You don't have a way to check your work. And then if you look at your notes, you're going to be like, how did I get this number? Because you're not writing down what your actual calculation was. So I would recommend doing what I'm doing here, writing down your calculations, so that way you can follow it and check yourself later on. And it makes it easier when I'm looking at your work and I know where your numbers came from. Like I can see, oh, you used this number and you should have used a different number. Like I can check for that. So it's better to write this all down, just to make sure that you can learn from it and you can see the patterns and you can check your work. So that is the first row, and now we're done with the first row. So I'm going to try to erase my highlighting. And now we've got the second row. So that's going to involve 4 and -3. Now we start over with the first column. So I have 4. Oops, thought that was going to be green. Don't know what. There. Okay, so 4 times 6. And then -3 times -1. So that will be second row, first column that goes in the first entry in the second row. So now I'm going to just erase my arrows. Hopefully, there we go. And then we still have that second row, but now we move to the second column. So 4 is multiplying by 0, adding -3 times -4. And you can sort of see the pattern for me when you're writing it out this way. You can see that in parentheses, the numbers are the same for each column in our answer matrix. It's the coefficients that are changing. And you can see the coefficients are the same going across, but then there's different numbers in parentheses. So you can see sort of a pattern here. And that can also help you check visually if you've made a mistake, because if your pattern doesn't hold as you're writing this out, it can tell you, oh, I put the wrong number there. Because that is the most common mistake, is writing down the wrong number. And now we've got our second row, second column. So that's 4 times 3 plus -3 times 0. So now that I've written all of this out, you want to actually do the math, and it may be easier for you to kind of, it's easy to do this in a true row by kind of doing the halfway math above and below in a different color. So like 8 times 6 is 48. And then this is 1. 8 times 0 is 0. This is 4. 8 times 3 is 24. 0. 24. So this only works if you have 2 rows, because if you have 3 rows, you don't have a spot to put your numbers. Make that better 1. But this is a nice way to just double check all of your math here instead of having to rewrite the entire thing. You can just kind of write your multiplications there and then add them. So our final answer is then you add these things together. So 48 plus 1, we get 49. 0 plus 4 is 4. 24 plus 0 is 24. 24 plus 3 is 27. 0 plus 12, we get 12. 12 plus 0 is 12. And then that's your final answer. You ended up with a 2 by 3 matrix, and that's what you've got. Now, it's always good to check your answer, and I would definitely, when you're multiplying, like on the homework, do this matrix multiplication by hand so that you get some practice on doing that. But like for the self-assessment or like your proctored exam in week 5, I would definitely use technology. But I recommend double checking your work with technology at the very least to make sure that you didn't make any errors. So I'm going to pull up her class because I did email everybody out in an announcement. And so let me pull this over. So I've got all of these options for online calculators that you can try. I personally like the matrixreshish.com. That is my personal favorite. And so we can check our matrix multiplication by just clicking here. And then you pick the size. So our first matrix is a 2 by 2. Our second one was a 2 by 3. And then you plug in your numbers. So I'm going to just double check that I didn't make any math errors because it's pretty easy to do. Second one, 0603. I'm just hitting tab. That gets me to the next number. And then calculate. And hopefully this matches. 49, 4, 24, 27, 12, 12. Perfect. Okay. So you can use this to check your work. And then what's really nice is it does have like a show solution. So they're showing you what they're multiplying, and it basically matches exactly what we did and how they got each number. So you can use that to double check and see where did I go wrong, what number did I plug in. So I would definitely use this as a check, and definitely use it on like these self-assessments and the proctored exam. On the homework, do the matrix multiplication by hand because it's not too bad. The other problems on the homework where you're solving, you're welcome to use technology for solving. Just show the setup and then tell me which website you used and which type of solving you used. But show up the initial step and then you can show the final exam answer, because the solving could take a lot of steps. And so that's just easier to use technology, but the multiplication isn't too bad. Any questions so far? Okay, so from here, now we're going to get into word problems, and let me move my picture. There we go, so it doesn't block our directions there. So these are pulled from section 8.2. I'm just pulling word problems so you can see how these can be helpful, and really the interpreting the result, because you're going to have to do that on the assignment, and making sure that your interpretation is clear and what it means. So that's really important. So a farmer grows apples and peaches. Each crop is shipped to 3 different outlets. The shipment levels are represented by matrix A. So columns are each outlet, and then rows are the crop, apples and peaches. So this is sort of what you'd see in an Excel spreadsheet. You know, you'd be just putting this data in. The profits per unit are represented by the matrix B and $3, $50, and $6. Compute BA and interpret the result. So they're telling us specifically we need to do B times A. And you can figure that out because if you tried to do it the other way, you wouldn't really get an answer. So first, like B here is a 1 by 2. So we have 1 row, 2 columns, and then we're multiplying it by a 2 by 3, 2 rows, 3 columns. Our answer matrix is going to be a 1 by 3, 1 row, 3 columns. So I'm going to start by putting these in the correct form. Oops, actually hit the wrong color. So we got 350 and 6 as the first matrix, and then 125, 100, 75, 100, 175, 125. And so then that is matrix A. And so if it helps, this 350 is going to be for apples, and then the $6 is for peaches. And you may be asking me, how do I know that? How do I know the 350 is for apples, the $6 is peaches? Because it didn't tell me that. And I know this because these columns have to match with the rows of our other matrix here. So we've got, again, this is a 1 by 2, and then this is a 2 by 3. So our 2 here is the fruit, and so for them to match, that means my 2 here is also the fruit. So each column here for the 350 and the $6 is telling me that these are fruit. And then the row is the price, the profits, I should say, profits per unit. And then the 3 columns we have are for the outlets. And so if you look at this and you look at what your units are, our resulting matrix is going to be 1 by 3. And the 1 is going to be profits per unit, and the 3 is going to be the outlets. And we don't really have a per unit anymore because now we're multiplying by how many of each unit we have, because that's what the fruit is representing, is the number of units. So that per unit kind of goes away, and now it's going to tell us the profits for each outlet. So you can see what your output, what is that matrix telling you? The matrix is going to give us the profits per outlet, and that's basically the interpretation. So I can get the interpretation without even doing the multiplication, just by looking at those dimensions and then looking at what are we multiplying. So just to make this very clear, the interpretation, so BA tells us the profits for each outlet. Oh, and I see that my face is in the way again. Let's just make me a little smaller. There we go. So we've got profits per outlet. That's our interpretation. So I don't have a lot of space here to go through all of the work or the multiplying here. I just have basically room enough for the answers. So I am going to just use my calculator. If I could, where did I put my calculator? I'm going to just use my calculator to do the multiplication all in one step, multiplication and division or addition. So Here we just have one row by each column. So we're going to do 3.5 times 125 for that first column, plus 6 times 100. So I'm just putting that on my calculator, and I get 1037.5. So that is how much money they're making in profit for outlet 1, because that's the first column. Then I take 3.5 times the column 2, so that's going to be 100, plus 6 times 175. And this gives me 1,400. So outlet 2 is making a profit of $1,400. Then third column, so we have 3.5 times 75 plus 125 times 6, or 6 times 125. I kind of reversed that. And that gives us 1,012.5. So they're making $1,012.50 total in profits at outlet 3. So the interpretation is that this matrix is telling us the profits for each outlet. I don't need for the interpretation the exact each profit, like profit or outlet makes this much, outlet 2 makes this much. You can read that in the matrix. What I want to know is, what is this matrix representing? And that's what it's representing here. Are there any questions? Okay. Next example. So a company has 2 factories that manufacture 3 sizes of boats. The number of hours of labor required to manufacture each size are represented by S. So our columns are the department, and that's how many hours it takes that department for each boat size. So rows are boat size. Then we've got a second matrix. The wages of the workers are represented by T. So we've got each factory and then those different departments. And so we're multiplying S times T and then again interpreting the results. So let's set this up. So S is first, 1.5.2. I'm going to actually do my brackets last because I didn't draw them long enough. Oops, 2.5 to 1.4. And so this is a 3 by 3, 3 rows, 3 columns. And then we're multiplying it. We've got 15, 12, 11, 13, 11, 10. And then this is a 3 by 2. So let's do the interpretation first. So the rows here for the first matrix are boat size. The columns are department. And these are the hours specifically for each department. Now, in our inside here, we've got our rows, which again are departments. So notice that our department has to line up with department, but now it's actually wages. And these are basically wages per hour. So you see when we're multiplying the department hours by the wages per hour. So the hours are going to cancel out and our result is going to be wages, basically. We're going to get the total, not necessarily wages, but the total amount of money is going to be sort of our output here. And then our columns here are for each factory. So what we're going to end up with is a 3 by 2. So we're going to have rows for each boat. We're going to have columns for each factory, and the actual numbers are going to be the total spent the money for that amount of labor, because you're multiplying your wages per hour times the number of hours, so you're getting money as your output. So we'll just kind of, if we're going to get a 3x2 out because of the insides matching, and so 3 by 2. This is going to be boat size, and this is going to be for each factory, and then inside is going to be the total amount spent on wages. So our interpretation here, so this matrix is telling us the total spent on wages at each factory, because it's going to be divided columns by each factory, factory A and factory B, for each boat size. So it's also divided up in boat sizes. So, and at each boat. Oh, it'd help if I spelled boat right. Boat size. So it's divided up by boat size. So we might want to say maybe total spent at each boat size on wages at each factory, or however you want to word it, but you want to make it clear that these are divided out by boat size and divided out by factory. And then if you wanted to know the total amount for the factory for all boats, you would add your columns together, because or add your rows together column-wise. Since each row is going to be a specific boat size for each factory. So if you want a factory A, you multiply, add that whole column together, and that will give you the total at that factory. So to do this one, I'm going to pull up our matrix calculator. Since again, I don't have a lot of space here, I wanted to focus on the interpretation for these word problems so that you understand how to interpret what you're getting. So just kind of move it over. Is there a way to get a new one? I'll just click on matrix multiplication again and just start over. So we've got a 3 by 3. I have no idea. Well, I'm not going to complain about ad blocking software here. We've got a 3 by 2 as our second matrix. Okay. So I'm going to just keep using tab to easily move to each section. And then I'm going to click in my next one. Okay, and then calculate. Okay, I think it doesn't like that I don't have a 0. Yeah, so all the ones where I didn't put a 0 in front of the decimal, it wants a 0. So I just have to make sure I enter that in. Now it should work. Okay, so this is the resulting. So remember that these are the columns are each factory, and then these are the boats. So this would be like a small boat at column A, or at factory A. To make one small boat, it costs $23.2 department, because it's wages per hour, whatever the wages are for that. 38.2 for a medium, and then 76.9 for a large. And this is for like a single boat. So the cost of making one of each boat, you would add all these together. And then if you wanted to know how much it would cost for like making 5 boats, or different amounts of boats, you can then do another multiplication with this matrix to then figure out, because these are specifically for one boat. We don't know how many boats we're making, we just know how much does it cost for one person, and then how much does it cost for, how many hours does it take to do this part for one boat. So these are all in terms of one boat. So I'm going to see, I'm going to just move this off so I can copy down the numbers here in our, so we've got 23.2, 38.2, 76.9, 20.5, 33.8, 68.5. So I should also make sure on my, for one boat, basically. So, you know, we've got, it says the company, it's 2 factories, you're making 3 sizes of boats, the number of hours of labor. So this is, you know, that we don't have enough, we don't know how many boats each factory is making, but then, you know, if you have a column, let's see, if we had a 3x2, we would need a 2 by, probably like a 2x1, maybe if you wanted the total, or a 2x3. So that you can have rows each factory and then maybe how many of each type of boat that they're making. So you'd have a 2x3, and then that would give you, for each boat size, it would give you the total based off of making that many boats. So you can keep using matrix multiplication to kind of get what you want. Are there any questions on this example? Okay, I've got one more example here. Number of calories burned by individuals of different body weights while performing different types of exercises for a 1-hour time period are represented by A. So we've got 2 different people, 130-pound person, 155-pound person, and then we've got basketball, jumping rope, and weightlifting. And so we've got 2 parts here. A 130-pound person and a 150-pound person play basketball for 2 hours, jump rope for 15 minutes, lift weights for 30 minutes, organize the time spent exercising in a matrix B, and then we're going to be multiplying BA and interpreting the result. So knowing that we're going to be doing B times A, that will help us know how we have to organize the data. So we know it's B times A. So let's see, we trying to think how I'm gonna put A in the back here. I'm gonna put in A first because that's what we know. So I'm just going to copy in A. And here we've got 3 rows, 2 columns. So that means in order to do this multiplication, I need to have 3 columns in matrix A. So that will, or matrix B. So that will help us organize our data. We're going to have 3 columns. And so we do have basketball, jumping rope, weightlifting. We have to have those middles matching. So like our row here are the sports, and then the column are the weight categories. So we also need to have the sports here. And then that means the data they're giving us is the time, because in part A, it's giving us 2 hours, 15 minutes, 30 minutes. So time is going to be going across. And we've got 2 people, or 2 different weight categories. So it's going to be 2 by 3 and multiplied by 3 by 2. And so our resulting matrix is going to be basically giving us total time for each weight category. We're going to have a 2 by 2 essentially. So we know that we have to have 3 columns here, and then we're going to have 2 rows. So we've got, I want to make sure, because we're trying to fill in these in. So we're going to have basketball, jump rope, and then weightlifting. So I'm just going to kind of label those because these are basketball, jump rope, weightlifting. We have to make sure they're in the same order here. So 100, and so I also want to make sure that I'm kind of in the same order here. So this is the 130 pound, this is the 155. So I want to make sure that I'm using that same order when I'm doing my rows. So I'm just kind of putting labels there to help me create the matrix of the right size that we're looking for. So for the 130 pound person, let's see. They're both, it looks like they're both spending the same amount of time. So we may not even be able need to, I'm looking at it. So we've got a 130 pound person, 155 pound person play basketball for 2 hours. They're doing the same amount of time. So what we could do is just do time only and have a 1/3 because they're not separating it out by person. So we're going to have a 1/3 matrix and it's just going to be time. So when you're doing problems like this and you're trying to figure out, you're trying to create your matrix, you're looking at the information that you're given, you have to kind of think about what you're doing with that information and then what they're getting you to kind of figure out, well, what's the best way to write this. And I'm allowed to change it from like a 2/3 to a 1/3 because that first number doesn't matter. It's that the middle has to matter. The middle has to match. So based off of what they're giving us, I could have separated it out and just repeated the same information for each row, but there's no need to do that. So we can just use it once instead of having two identical rows here. So basketball is 2 hours. Now notice we have different units here. So 2 hours, 15 minutes, 30 minutes. So we have to make sure they're all in the same units. The stem of the problem, the original part at the beginning, says that this is for a 1 hour time period. So those numbers for matrix A are in a 1 hour time period. So we want to make sure that all of our units are in terms of hours. So that matches. Because we've got, this is basically, this is our calories. And this is for 1 hour. So we want to make sure all of our stuff is in hours. So I'm okay with, like, the basketball says it's 2 hours, but we're going to have to convert our minutes into hours, and that's going to give us decimal values. So going back to what we've got again, basketball is 2 hours, so I can just put a 2 here. Jump rope is 15 minutes. So 2 hours is 120 minutes, so we're doing 15 divided by 120. And it's probably best to put it as a fraction and then reduce. It comes to 1/8, so I'm going to just do that. And then lifting weights is 30 minutes. So again, I'm going to just create a fraction, 30 over 120, because there are 120 minutes in. Wait, I don't need 2 hours here. I just need to do per hour. I did the 2 hours because basketball is 2 hours. I don't need to do that for the other ones. We're just converting to 1 hour. So 15 minutes out of 1 hour, I just need to do the 15 over 60, which is just 1/4. And then weights is 30 minutes out of 60 minutes, so that's going to be 1/2. So don't make my mistake. Don't, just because the basketball is 2 hours, I still have to do out of per hour 1 hour, not 2. So out of 60 minutes. Okay, so this is our matrix setup. Our matrix B is what we have on the left, 2, 1/4, 1/2, and then we're doing B times A. And I'm going to use, again, technology for this to do the multiplication. And our result is going to be a 1/2, which is going to give us the total time for each person. It's going to be the total time. Let me do this in a different color. For the 130 pound person and then the 155 pound person. And it's going to be time for that particular weight class. And you can tell that because we're going to get a 1/2. 1 is time, 2 is weight here. Or is it going to be total calories? Let me look at this again. We're going to do 2 hours times 472 calories per hour. So per hour is canceling, so we're actually going to get out the total calories here. So, because this is, so here we've got, this is going to be the time number of hours, basically. We're going to be multiplying the number of hours. Our numbers that we're multiplying are hours per calorie per hour. So you can see when you actually multiply those inside numbers, hours times calorie per hour, the hours cancel, our answer is going to be calories. So, and that's going to be for the total time spent exercising that they did. So I'm going to pull over again our matrix calculator here, and just in the interest of time and space here, use technology to do it. So this is going to be a 1/3, and then we've got a 3/2. Okay, so I am not sure if, I don't remember if this allows fractions. I will attempt and see if it does. It does allow us fractional here, so I'm assuming that we can do fractional here. 472, 3, 590, 704, 177, 211. Okay. Yes, so you can do fractions. And then and you know that this is going to give it to you as a fraction as well. So we get 1,180, and then whatever this is. I'm actually going to divide this so that we can see it in an easier form. So I'm just, so for the 130-pound person for that exercise, let me put this back in white. They burned 1,180 calories. And for the 155-pound person, we divide that by 2. They burn 1,407.5 calories. So our result, interpret the result, our interpretation. The matrix is telling us the total calories burned for each body weight doing, I guess I'll just say the given exercises. Exercises. So being that they exercise for that particular amount of time, this is giving them the total calories burned for each of those people. And so that is your interpretation of that matrix. Now, just writing what I did on the side, like labeling the rows and the columns, that's not really an interpretation, because interpretation always means that you want to give it in words as a sentence. You're explaining what this means. So just labeling columns and rows it's not specific enough, it's not meaningful enough. So you want to make sure that you actually put it in a sentence, because that's really what interpreting means. Interpreting means you need to give this in a sentence, explain what it means, and explain means use words. Are there any questions? Okay, so that was all I had, basically. That was all of my examples. So if you guys don't have any questions, that's fine. Hopefully this will be helpful for that assignment. And if you do come up with questions later on, feel free to let me know and I'll be happy to help.